think we've just about got almost everybody in. Well, good morning, everybody. This is the AP Computer Science Principles Content Review Session hosted by Advanced Kentucky. I'm Sherry McGuffin, and I will be your host today. Today's presentation is going to be presented by Marsha Bertram from Wayne County High School in Monticello, Kentucky. If you want to access the handouts from today, if you go to the bit.ly link at capital M Math CRS, then you can access any of those content review sessions. While the online review sessions are in session, it's intended for a Kentucky audience, but we have people from all over the United States. Sometimes we get folks from other parts of the world as well. So just note that there could be a little bit of anybody in the room today, and we love to see where everyone is from. So if you have not introduced yourself, please do so in the chat. Tell us where you're from. We're going to do all we can to provide every student an equitable opportunity to learn, and during the session, we encourage your participation, but please know that any participant causing a disruption will be removed. AP is registered by the College Board and it's not affiliated with and does not endorse this particular product. We have contact information here on Twitter or Facebook. Follow us at Advanced Kentucky. There's my contact information, Dr. Sherry McGuffin. I'm STEM coordinator. That means I work with basically anything STEM related. Right now, my primary contact or my primary area of interest is computer science and supporting computer science across the state. I'm also a code.org AP Computer Science Principles Facilitator. There's my email address, smcguffin@kstc.com and at Dr. McGuffin. Follow me on Twitter. We like to talk about anything STEM related. A little bit of etiquette, keep your microphones off. Whether you're going to be muted upon entry, you've already noticed that. And you can leave your microphones off unless otherwise asked. We may have some Q&A here after a while. And if you want to open your mic at that point, Marsha will open it up and say, hey, if you want to open your mic and ask some questions, then if you want to do that, you can actually introduce any questions into the chat. I'll be monitoring the chat as Marsha is speaking. All participants also have their videos off upon entry. It says to please leave your video off unless otherwise asked. I don't mind if you keep your videos on. Marsha, I don't think you mind either. It's a preference. I like to see your smiling faces, but sometimes it decreases bandwidth. So just up to you whether or not you want to keep your videos on or off. There's the chat button at the bottom of your Zoom screen, or if you click on your phone, it's at the bottom as well, and change that over. And we're going to be monitoring the chat. This is also going to be recorded and posted on the bit.ly link where you went to register. So the recordings are going to be at bit.ly and at Advanced Kentucky, capital A and KY, that is case sensitive. But if you go to that bit.ly link, click on Math and Computer Science at the top, and then we'll be posting that bit.ly or posting that video to YouTube after the content session today. And with that, I will stop sharing my screen and pass the microphone over to Marsha Bertram. And again, like I said, if you have any questions that come up in the chat, we want to try to make this as informal as possible. So let's see really quickly. I had a couple of notes in the chat. The link, Kimberly, is that the link to the materials? If so, I'll go ahead and type that in the chat. Oh, you got it. Okay, great, great. Let's see, we've got folks from all over the place. I'm just reading a few names here, Marsha, before we get started. Let's see where we've got some introductions. North Laurel in London, Angela Holland from North Bullitt, Susie Hart from Rowan County and Moorhead, Morgan County High School, Seneca High School in Louisville, Crystal Dean from Henry Clay High School, Madison Wolf from Bowling Green, Island Trees High School in Levittown, New York. Maria, hello, welcome. I would say you've come a long way, but in the Zoom room, we've all come a long way, haven't we? Nice to meet you. And we've got Nathan Frederick from Morgan County, Steve Green from Frederick Douglass, Russ Pike from Cecilia, my neighbor over there in Cecilia, Kentucky. Can't be good until I have my coffee. Well, Paul, you better get on that. He's from Seneca in Louisville, Kentucky. And we've got Anna from Palm Beach Gardens High School in Florida. Welcome, Anna. Boy, we wish we had some of your warm weather, don't we, you all? And we've got some nice snow and ice here. Oh, Russ, oh my goodness. You've got a helper there. And yes, Maria, I will post the link again. And we'll see what we've got. And Russ, they want to know what your helper's name is.
This is Samuel Brooks.
Well, hello, Samuel. Nice to meet you. We're glad you're helping your dad there. We've got Kashvi from Henry Clay High School. All right, Marsha, I'm going to pass it over to you. And if there are any additional materials, Marsha, did you post any additional materials for today?
Just the slideshow. I was lucky to get this done in an ice storm.
Okay.
No power.
Now, gotcha. I'll let you explain all the interesting situations that you've had getting ready this week. So I'm going to pass it over to Marsha. And if you have any questions, post it in the chat. We'll try to make it happen. All right, take it away, Marsha.
All right, good morning. My name is Marsha Bertram, and this morning we're talking about digital representation of data and numbering systems and data compression and storage security, because that's what I was told to talk about today, but we're going to talk about a few other things as well. My name is Marsha Bertram. I've been teaching for 17 years or so, including some early years subbing. I started substitute teaching because I had 3 children in 4 years, and I needed hours that matched their school hours. 4 years ago, they came to me and said, we'd like to start a computer science department at Wayne County High School. Would you be interested? And I said, sure. This is my second career. I was a systems analyst at the University of Kentucky, but let's go back to those 3 kids in 4 years. And then I took off 5 years to be their mom. And when I came back, this is where I landed. I don't do much social media, but I answer emails really, really well. If you find flaws in this presentation, please forgive me. We've been under an ice storm. I'm in South Central Kentucky. I lost power Monday night about 7:30 and didn't get it back till Thursday afternoon. I ended up having to go to my husband's office to get this done to make sure I had it for today. So that's why I didn't get anything else done. Before we get into what I'm going to talk about today, I'm going to talk as if I'm talking to students, although I know I have a lot of teachers in here, and I'm figuring if you pick something up, that's great. And if I'm talking about stuff I'm wasting your time, I'm so sorry. When taking the AP exam or any other exams that's important to your career, don't get bogged down on one question. Tell them not to get bogged down on question. Tell them to read it through twice. And if they can't find the correct answer, tell them to start marking off the incorrect answers. Most of the time, you're going to take your choices from 4 to 2, just saying, I know those can't be right. Okay? Tell them also, if you really don't know what a question is asking you, it is absolutely all right to make a guess. It's better to put in an answer and move on than to stare at that question on that time test. If there's time at the end, go back and stare at it again. But make sure that you have that time by putting in an answer and moving on. Now, look at this warning because this is really important. If you're
Marsha, do you want to go ahead and share your screen?
Oh, I'm sorry. I'm sorry. I thought I was.
There we go. No, that's fine.
I'm just talking away like you all can see what I'm doing. I cannot share my screen. I have lost that ability.
Okay. Well, I tell you what, I will, I'll share it. And do you want me to share the presentation link as well? Or do you want
I don't know what happened that I lost it.
Well,
I mean, whatever works is fine. I'm so sorry, people.
that's okay. What does it tell you when it says share the screen at the bottom?
I hit Zoom and it puts up slide one. It doesn't give me anything. Wait a minute.
Okay.
Hold on. Let's do this. Yeah, Zoom's not even giving me anything now.
Okay. Well, I'll go ahead and share your screen because I have it up, and then I'll just try to follow you. How about that?
Works for me.
All right, there you go.
Now
All
I
right,
gotta get
give
my
us the
screen.
or a hey, we can see this, and if you see this
What?
should say digital representations of data, and maybe during the
Okay.
break, Marsha, some troubleshooting. Okay.
We'll do some troubleshooting. Okay, so there's my high, and that's what I look like. And I was on quick tips. So here at the bottom is where I was this morning. I just found this out a couple of weeks ago in another meeting I was in. If your students decide they're going to take the digital exam this year, they cannot go back and change an answer. Please make sure they understand that if they sign up to just take the digital exam. And please consider that when your school is thinking about taking the digital exam. Okay? They cannot go back and make changes. All right. Always, and again, some of these kids, some of my kids, this is the first time, some of them haven't even taken the ACT yet. And they're going to take this AP exam, and it's going to be the hardest test they've ever taken. And they're going to read really quick because they're going to think it's timed, and they're going to overlook that word not over and over and over again. So make sure they read twice and look for the word not. I would recommend they take at least one complete timed practice test. Completing the test within the frame gives them the confidence to familiarize them with the format of the test. My particular classes, we take one practice test together as if they were in a study session. We go over each question, they pick an answer as a group, try to come to consensus, and then we discuss the correct answer and the why. This is going to take us 2 to 3 class periods. And then students go on to take a time release practice test. Advanced Kentucky has a mock exam if you're part of Advanced Kentucky. And I do that as close to tested conditions as I can give them. We score them and return them, and they can see what they really need. Remember too, that 2-step questions are a big part of the AP CSP exam. Unless they've taken advanced math, they may not have seen those 2-step questions yet. Okay, now let's get to what we're supposed to talk about today, and that is data. This information is taken straight from College Board's site, and data is 17 to 22% of the AP exam. So about 1/5 of this exam is going to be on data, okay? That includes binary numbers and data compression, the 2 things we're talking about today, and extracting information from data and using programs with data, which is not necessarily in today's world, but we can make it that if you want. Okay, digital representation of data and numbering system. Again, this is from College Board, how data can be used. And that takes us to binary. It's computer language is its lowest level. It's either on or it's off. It's a 1 or it's 0. It's magnetized or it's not. It has an electric charge or it doesn't. It's a bit. It's the smallest unit of information. There are 8 bits in a byte, and computers now are measuring data storage in gigabytes and terabytes and probably beyond that. It's easy to consider a byte as 1 character of information. ASCII characters are generally considered bytes. Although I have a piece of information later that's going to contradict that. On the exam, you need to remember that each place in the binary system is 2 times the place to its right. Remember that flippy-do if you use code.org, and if not, do an internet search on a flippy-do and you'll get the idea of how that works. Can you take a flippy-do into the test with you? No, you cannot. Can you draw yourself a binary table, which is the next slide? Yes, you can. And I recommend that you do somewhere on scrap paper. Remember, you start with 1's place, and everything to the left is 2 times what was to the right of it. I would draw this somewhere on the first one that has anything to do with binary and leave space underneath it. Don't try to do this in your head. You'll get yourself messed up, okay? When converting a number, look for the highest value that is lower or equal to your number and put a 1 beneath it. And then do the same until the number is presented. For example, if my number is 189, which I pulled out of the air, Then 128 is my number that's lowest, but 256 is too high. 128 is where I need to put a 1. Then I subtract 128 from that, and I've got 61 left. I leave this as a 0 because it's bigger than 61. I come down here and I say, I'm going to put a 1 here. And I'm going to take 32 away from that 61. That's going to leave me 29. Well, 16 is lower than 29. I'm going to put a 1 here. I'm going to hop over to here. Okay. 13, well, 8's lower than 13. I'll put a 1 there. Hop over to 4. Put a 1 there. Put a 0 there. Put a 1 there. So the binary conversion is, whoa, my computer's messing with me, is 1 0 1 1 1 0. Yeah, something like that. It's at the bottom of the page. Here's the important part. Practice this until it becomes easy, because most questions will be 2-part. This is the first part. You're going to take it and convert it to binary and then make a decision based on that. So it's not going to be as easy as just making a binary number. So you've got to practice with a binary table. It's got to be really easy, or you have to draw one in a hurry because you are on a timed test. Decimal, I threw this one in there because decimal's base 10. It's what we use every single day. It's a lot like binary. There's 2 differences. One, well, each number to the left is 10 times the one before it. And 2, decimals are allowed. Here, we can go into tenths and hundredths and thousandths on the other side of a decimal point. Now, you can't do that with binary, okay? I only mention this to introduce the next idea, which is fairly important. Hexadecimal. This is the idea of a 16-based numbering system. Since each number in the system can only take 1 space, in hexadecimal, the first 10 characters are the numbers 0 through 9, and the first 6 letters of the alphabet are the rest of the characters. So this is 0 through 9, 10, 11, 12, 13, 14, 15, which you count the 0, that's 16 spaces. This system is used to represent different ideas in the computing world, and users are often provided a context or a table for hexadecimal values. Because hexadecimal can equal alphanumeric, hexadecimal can also equal colors. You have to know what they're using hexadecimal for. Now, this is important on that test because of hexadecimal color values. Remember your color triplet. If you haven't seen that yet in your AP course, it's coming, and you need to remember it when you get there. A hexadecimal color is specified with 2 bytes for red, 2 bytes for green, 2 bytes for blue. And it's these colors mixed together that make the colors that are represented, okay? Red, green, and blue is the color triplet. There are hexadecimal integers between 0, which is there's no amount of that color, and FF, which is the highest amount of that color. The intensity, the highest intensity of that color. As an example, 0, 0, 0, 0, FF, that's blue because there's no red, there's no green, and it's the highest intensity of blue we can find, okay? Make sure you understand the color triplet. Make sure you understand that it's hexadecimal value. 0 is none, F is highest intensity, okay? Okay, hexadecimal values 0 through F in the tables below. As you can see, this allows for large values. So here's 1 over here. To the left is 16, to the left is 32, to the left is, again, oh, this is wrong. Look what I did. I said 16 times 2 instead of 16 times 16. So if you use this in your classroom, please remake the hexadecimal table there. That's what happens when you're in a hurry. Okay. Here is one way to look at a table illustrating hex digits and binary digits. Okay. Where it takes 1 F to represent 15 in hexadecimal, it takes 4 1s to represent it in binary. Also, if you're planning to use this, I'll get Sherry a better copy with this fixed on the hexadecimal table. Okay.
Marsha, one thing to mention that the question was, is hexadecimal going to be on the test this year, or the understanding wasn't going to be on the test this year? One thing that I've seen in the past and worked with the work, well, seen in the past on practice exams, as well as students coming back with feedback, is you almost always see a base 4 question on a multiple choice, or a base 8 question, or something like that, or some kind of base question. So just understanding, students understanding that there's more than just binary, that their binary is base 2, but there could be other base numbers as well that are related to base 2 binary. Hexadecimal is 1, octal base to 8. So that is the relationship I think that I bring in, is just demonstrating other numbering systems rather than binary. Marsha, did you have anything to add to that?
They may not ask it as hexadecimal, but there's probably going to be some kind of color intensity question on there, which, you need to understand that those colors are represented in hex. I'm not going to guess and say that it's absolutely going to be there. I have no idea what's going to be on the test, but I would have some understanding of that color intensity and the color triplet for sure. We good to go? I may be moving too fast. If I am, let me know. I'm just talking into a screen right now.
Yeah. No, I think we're okay. If there are any questions that pop up, please put them in the chat and I will moderate those for you, Marsha.
Thank you. All right. Overflow. This is an important idea. Okay. When programming, many languages are going to ask your program to stipulate the size of the data that's going to be stored. Okay. Way back in the year 2000, I was working at the University of Kentucky, and many of the programs had to be edited because everything had to now allow for a 4-digit date field. We had to allow for the year 2000. Everything before that was a 19 something, especially with many parts of the government. The IRS was just scrambling. If any of you are as old as I am and remember this, all the programs were designed to only handle the last 2 digits of the date field, with the assumption that those first 2 digits were 19. These programs would make the assumption that the year 2000 was 1900, and any math calculations or age calculations would be based on 1900 instead of 2000. This was a big deal, and everything had to go back and be changed to a 4-digit field. The government searched far and wide for COBOL and Fortran programmers because they had a lot of computer code that was COBOL and Fortran, and those programmers were dying out. They weren't being taught as much anymore. All those date fields had to be changed, and the input requirements had to be made so that the program would run correctly. Right here, where the 2000 is assumed to be a 1900, that's overflow. Okay, that is, I don't know what to do with that, so I'm going to chop off anything that's bigger than I know how to handle. And I'm just going to handle it as if it wasn't there. Overflow is an important concept to understand. Data overflow. All right, I've got practice questions. Sherry, I can't even see your answers, so there's no judgment here. I'm going to give you a little bit of time, and then we're going to talk about why the answers are what they are and what you can get from that question, okay? I went to College Board's AP site and got these questions, and I was careful to only include questions that were released for use. So I'm just going to put a question up, point out a couple of things, give you a little bit of time. If you want to answer in the chat, you are more than welcome to. Like I said, currently I can't even see the chat. So no judgments from me, okay? All right, first question. We got a video game character, and he can go north, south, east, and west in this version of the game. Each direction is stored in memory in 4 bits, okay? A new version of the game has been created, and now the character can go 8 directions. He can go northeast, southeast, northwest, and southwest, as well as going north, south, west, and east. Which of the following statements is true about how the 8 directions must be stored in memory? First, 4 bits aren't enough to store 8 directions. We need 5. 4 bits aren't enough to store 8 directions. We need 8. 4 bits aren't enough to store 8 directions. We need 16. Or 4 bits are enough to store score the 8 directions. Okay.
All right, type your answer in the chat. We'll give it about 30 seconds.
There we go.
And whatever you think. All right, Marsha, I am seeing a lot of D's.
That's good, because the answer is D. The only important information is that there are 8 choices, so you need representation for up to the number 8. In binary, 8 is 1000. That's only 4 bits. Try her again. All right, you see a lot of tables on the test. Don't let that worry you, okay? Read the question, then look at the table. Which ASCII character is represented by the binary or base 2 number 1001010? This is a good place to have a binary table. I will give you this hint. That last character is a 0. And I'll tell you what that means in just a minute.
Okay, we'll take another 30 seconds to answer the question. You can put your answer in the chat. All right, Marsha, I am seeing a whole bunch of C's in there as the answer for this question.
That's good. Throughout the binary table, remember each progressing data is 2 times the previous digit. There's the table. The answer is 64 plus 8 plus 2, which is 74. Guys, the fact that there was a 0 on the end means that it had to be an even number. So you got to mark out 2 of those choices without doing anything, okay? Because it had to be even, okay? This is a great example of that multi-step choice problem. You had to find the answer and then you had to apply that answer to the table. That's why I said a lot of these are going to be 2-step and not so simple. Okay. This one I put on because it's a 2-answer question. Which of the following can be represented by a single binary digit? Select 2 answers. You also need to know that there's no partial credit given on any 2-answer question. You either get them both right or you're wrong. So you have to have both the answers. Is it the position of the minute hand on a clock, the remainder, been dividing a whole number by 2, the value of a Boolean variable, or the volume of a car radio? You need 2.
So chat, type 2 of your answers. I'm seeing some responses coming in.
I didn't think this one was really hard, but I put it up because it was a 2-answer, and students need to be aware that there are going to be some of those on the test.
Right. Marsha, I'm seeing a whole bunch of B's and C's.
Excellent. The answers are B and C. Boolean's either true or false, so it's got to be binary. And the remainder, when you're dividing by 2, is either 1 or 0, so that's binary. You know, the other 2 obviously weren't. So this one wasn't too bad. I just put it up here because it had 2 answers. Okay. All right, practicing with overflow. This one takes a little thought. A certain programming language uses 4-bit binary sequences, so you only have 4 bits to store data to represent non-negative integers. For example, the binary sequence 0101 is 5. Using this programming language, a programmer has added 14 and 15 and assigned the sum to the variable. Which of the following best describes the result of this operation? Correct sum of 29 is going to be stored. An overflow error will occur 4 bits not large enough to represent either the values 14 or 15. An overflow error will occur because 4 bits is not large enough to represent 29, the sum of 14 and 15. Or a round off error will occur because the decimal values 14 and 15 are approximations due to fixed number of bits used to represent numbers.
All right, type your answers in the chat. Give you about 30 seconds.
We might get somebody on this one. But if we do, no big deal.
I'm seeing a lot of C's.
Excellent. The answer is C. You have 4 bits to represent the data. 15 can be represented in 4 bits. 14 can be represented in 4 bits. But 29 should be represented using 5 bits. Since there are only 4, it's going to show up as 13. Okay. Now remember, 2 of those answers said an overflow error. And if you get in a hurry, you might say, well, it's an overflow error and pick B. Well, yeah, it is, but it's not an overflow error for that reason. So the reason has to be correct as well as the answer correct, which is why it's C. Oh. Which of the following are true statements about a data that can be represented using binary sequences? A binary sequence can be used to represent strings of data. Binary sequences can be used to represent colors. Binary sequences can be used to represent audio recordings. Your choices are 1 only, 1 and 2, 2 and 3, or 1, 2, and 3.
All right, answers in the chat. Take about 30 seconds. Ooh, we've got some disagreement on this one.
I had to really think about it. As a matter of fact, I think I overthought it.
I think we've got a fight going on between B and D here.
Ooh.
Let's see, we've got a few more answers coming in.
Okay.
Yeah, we're pretty much even split between B's and D's.
Well, we're going to go ahead and tell you that the answer is D. All digital data, any digital data, is represented in its lowest form as bits. Statement 1 is true because all characters can be represented. Statement 2 is true because colors can be encoded as that. Statement 3 is true because any sequence of bits can be used to represent sound. So the answer is D. If it's on a computer, it can be a bit.
I'll give you a little example of this if you don't mind, Marsha. One of my sons, he's an audio engineer. And so in the equipment that he has, one of the things that he has to do actually is take specific sound clips and sound bites, and he has to manipulate those. And one of the ways that you can manipulate them is on the bit level. And so it's really interesting to see that. It's really interesting to see. In fact, many audio engineers now are also having to learn computer programming as part of their curriculum. So you may see jobs for audio engineers that require some type of programming experience that goes along with it. Just a little side note.
Yeah. Well, that's what makes it interesting, is when you can put something with it to help you remember. All right. Consider, ooh, I like this one. You math teachers that have dipped over into computer science, here's your question right here. Consider these following values: binary 1011, binary 1101, decimal 5, decimal 12. Which of the following lists the value in order from least to greatest?
Okay, 30 seconds. All right, we're seeing a few answers come in. Let's see if we can get a few more, and then we'll do some comparison. Marsha, I'm starting to see a whole bunch of A's.
Really?
I
Well,
am.
that's probably good because the answer is A. The first step is to convert apples to apples. Convert the two binary numbers to decimal, and then the problem becomes easy. Say what I meant earlier about those two-step questions. 1011 is 11. 1101 is 8 plus 4 plus 1 is 13. So it becomes 5, 11, 12, and 13, which is answer A. Okay.
Good job. Good job, everyone.
We're a little early for a break. You want to keep going just a little bit longer? Or do you want to take a break?
Yeah, let's
keep going.
Let's keep going until about 10:55.
Works for me.
10:50. So let's open up to any questions that you have at this point. And I'll go ahead and stop sharing, but let's open up to any questions that you have at this point. And this may be particularly about the formatting of the exam. I did see one question earlier there about will the two answer questions on the exam say that they have two answers? And the answer to that is yes. Yes, they will say that they have two answers. Normally those two question answers are at the very end of the exam. I'll give you another example. A few years ago, I'd given my students the mock exam through Advanced Kentucky, given them the mock exam. And on the mock exam, and the student, he just went through in the mock exam, and he didn't really read the instructions. He just went through and answered everything as a single answer. Did not read the instructions, and then didn't score well on the mock exam. And couldn't figure out why until he got his results back, and he was like, oh my gosh, these were supposed to have two answers. And I'm like, yes, they were. So anyway, but those are generally at the end. And Steve, you posted, if you want to open up your microphone, Steve, and tell us a little bit about what you said here. This was about coding for musicians as well. So to kind of tag on to that multiple choice question.
Yeah, Sonic Pi has been around for a few years. It is just a code-based music creation, so you can do your loops, do your different sound clips of everything. It's a really cool way of doing it. I haven't gotten it to work well on a Chromebook, but it does work pretty well on a Windows device if that's what you all have. And it's worth exploring into. That's why I put a link in there.
Thank you so much, Steve. Appreciate that. And some of the other teachers that are on here, are there any specific methods that you have used that in which you've talked about data, or in teaching about data and about numbering systems? Anything that you want to share? And you can type that in the chat, or you can open up your microphone if you'd like to do that as well.
Hey, Sherry, I don't know if you know, but there is a couple Excel templates out there for the Flippy-Do.
Oh, excellent. Excellent. And that Flippy-Do, if you are not familiar with it, I know most of you that have gone through the code.org training, you are. That Flippy-Do is an amazing little tool that just gets the binary representation into students' heads.
Sherry, I'll see if I can find it. I have it in my Google Drive.
That would be perfect. Thank you, Paul. If you post that in the link or in the chat, we would most appreciate that. Any other teachers that have any recommendations or any comments about data and any helpful tips for our students that are out there?
I hope I didn't put too many questions in. I tried to do a broad range. And like I said, I put this as if I'm going to use it for my students. So I put it as if a teacher would use this for some review on these topics with kids. So I hope that was okay.
Yeah. And if you're doing these questions on Zoom or on some type of mobile platform or something like that, most of the time it's really easy to put them in a poll. But you all correct me if I'm wrong, but as far as Zoom goes, I haven't seen being able to put two responses in a poll, but you all tell me if I am wrong, because I would love to be able to do that if I can.
Hey, Sherry, the second link is the one they need to use, but
Yes.
they need to make a copy of their own. because
Okay.
it's my copy.
Uh-huh.
Because they need to be able to edit it. And if you don't set it up as your own copy, you can't edit it.
Okay. All right. I'm going to go ahead and share this. This is the example of the Flippy Do that we're talking about. And students, if you can click on this link as well, just make sure you make a copy of it. But if your teacher hasn't necessarily given you one, then a Flippy Do is something you can definitely use yourself. And so essentially, Paul, I'm going to have you explain your digital Flippy Do here if you don't mind.
So like, for example, uncheck the check boxes, please.
Check box.
Underneath, yeah, like where the 4 and the 16 is, those check boxes. Nope, go up.
In the box?
Actually, just stay there.
Okay.
You can see what I'm doing.
Yes.
So like if I have 78, we're going to look at what is the largest one that goes in. So then we have 64. And usually, and so now it shows here in the box, 14's left. You pick your 8, your 4, and your 2. And so now you have your binary match.
Oh, cool. So there's your little your digital Flippy Do. I love anything that makes a more paperless classroom. So awesome.
Right. And then you can just reset it. And then you can type in any binary. Like if I wanted to do 134, you know,
Mhm.
so now it shows that 128 is my largest. And then it shows how much I have left over. And that would be your 8-bit version. So
Awesome.
I really like it. I mean, the kids liked it, I thought.
Mm-hmm.
Yeah, two of my kids are in here today, and I'm very proud that they're here.
So you heard it straight from your teacher there, definitely. Awesome. Thank you for sharing that, Paul. Appreciate it.
You're welcome.
And is this something you designed, or is this something that you pulled from a source somewhere, or?
I pulled it from somewhere, and I don't even know where I found it. I just did a search for Flippy Do electronic and
Yeah.
template.
Okay, got
So
it.
I made a copy of it. So I mean, it's say, as in famous words, beg, borrow, and steal, and find stuff to help students get better.
Absolutely. All right. Thank you, Paul. Thanks for sharing.
You're welcome.
So, question here, back to the digital administration of the test. Can they go back and answer a question if they skip it? Marsha, I'm going to pass that on to you because you have information that you got about that.
It's my understanding that once they pass a question up, they cannot go back. No matter whether they answered it or not, once they pass a question, they cannot go back to that question. That is my understanding from a Advanced Kentucky Mentors meeting that I was in a week or so ago. So.
Good information. So thanks for that question, Crystal. But that's good clarification as well.
Sherry, if you'll go up 2 slides to the one that says extras.
All right, let me get back to my slide deck. And there you go.
Okay, so these are just extras. I'm not going to play them today, but I thought they were good. The first one is the best short video I've ever seen on binary systems. This guy really explains them well. He's got a commercial at the end. It's his video. I left his commercial on it. The second one explains not only the bits and bytes, but connects those concepts to how they work within a computer. So if you can use either of those and have time to use either of those, there they are. Or if you want them in your toolbox for next year. At the bottom of the page is a little quick tip that maybe everybody else knew about, but I didn't until the other day when somebody told me. If you want to use a YouTube video and you don't want all the commercials and side information that pulls up with it, once you get that video up on your screen, go back to the URL and change YouTube to UT-UBE. And then go to the end of the URL and press enter. Now you've got a no cookies version of the video with a new URL, and you can copy that to use in your classes and put in Google Classroom. And that's exactly what I did for those 2 that are up there. I thought that was cool. Maybe I'm behind the times, but that's the first time I'd seen that. And it really helps if you're going to post something to Google Classroom.
Good tip. I don't think I knew that either. Great. So there are a couple of videos that you can use on binary systems. All right, we're coming up. It's 10:46. It's a little early, but let's go ahead and we'll take a break until 10:55. So that'll give us about 9 minutes. So if you need to take a bio break, go get grab something to eat or drink or a bottle of water, whatever you need to. So Marsha, unless you have anything else, we'll go ahead and we'll take a break until 10:55, and then we'll come back and we'll start the next section.
Don't, but I'm going to get out and come back in and see if I can see where I can see things. Is that okay?
That sounds fine. Okay. All right, everybody. We'll see you back at 10:55.
I'm going to quit Zoom altogether and come back in, Sherry.
Okay.
Marsha, thanks for doing this.
Paul, she popped out for just a few.
Oh, gotcha.
She was having problems with school. They've had all kinds of electrical issues this week, so she's trying to fix that.
I was gonna say, you see my students picking on me too. I love it.
Yes. It's good stuff.
You understand? My kids, I tell them once they have me, they're mine. They're like mine, literally, my kids.
I'm back.
All right, I've just gotten started with a little music break as you start testing things.
All right, I'm going to see if I can, what shall I do? I don't want to share my screen yet, right?
You can try if you want to. I'm going to go ahead and pause the video.
Oh, you
55. So 10:55, and we're going to go ahead and get started back again. Marsha has her sharing capability back. Yay.
woohoo.
And to move on to the next section, and we'll see about the next section. And then I know some of you expressed interest in some questions about the create task. And so we'll spend a little bit of time towards the end asking about the create task if you have some questions about that. Marsha, take it away.
All right. There's some practice, even after the extra slide that I put up with that stuff on inside here. Here's some practice. There's a Quizlet. There's a code.org Kahoot that somebody made. And then there's a harder Kahoot based on code.org. So there's some different things that you can pull in, use for review, or as Paul said, you can assign and make them go through on their own, you know? So there's just some things that I found. Now we're going to go to data compression and storage security. Yeah, compressed data. The reason why do you compress data? Because you want it to go as small as possible through the computer. Okay. Should you compress all data? Absolutely not. Okay. From College Board on this, here's the essential knowledge. It can reduce the size, the number of bits to transfer. Fewer bits does not necessarily mean less information. And the amount of size reduction depends on the redundancy of the original data. We'll talk about redundancy a little bit. I should have put more of that in there. Lossless data and lossy data are something you absolutely have to understand. Lossless is not compressed, okay? It can be reduced, but you don't lose anything in lossless data. If you compress it, you compress it by taking the redundancy out, putting something in its place, and then fixing it on the other side. That Allo, whoever he is, the musician thing that's in the code.org or was in the code.org is excellent for that. How you can take the words of a song and replace them with something else and then make them different on the other side. I'll go into that with an example here in a minute. Lossy, you're going to take something out and not put it back, but that's because it wasn't important to begin with. And I'll give you an example of that too, or two or three. Okay, Think outside the box on this. I'm a math teacher, an English teacher, and a computer science teacher. And that's a story we don't need to get into here. But here's what I think about when I think about lossy and lossless compression. You're typing a text message. Are you typing out all the words? Are you writing it like you write a dissertation? Or are you using shortcuts as long as the person on the other end understands it? They understand your compression algorithm. They can just decode your message. LOL, right? Everybody knows what that means now. So we have the information, we can laugh out loud on the other end because we know what that person meant. However, if you write an English term paper, this should be lossless compression. Do not even think about using contractions, which save space, but due to the purpose of what you're writing, you do not want to use them unless you want your English teacher to dock you. Okay, so there are times and places for lossy compression. There are times and places for lossless compression, and this is a very outside the box example. Lossy versus lossless. This table is small print. It's from a site called geeksforgeeks.org, and it compares the two types of compression point by point. And then there's a pic that compares lossy and lossless, and that's where I got it. I'm giving copyright credit where that credit is due. So, lossy compression. It eliminates data that's not noticeable. It does not eliminate in lossless, even if it is noticeable. In lossy compression, a file does not restore or rebuild in its original form. Important information right there. Lossy is the one where you cannot get the original back. In lossless compression, you can compress it down, and on the other end, you can get it back just like it was. In lossy compression, your quality is compromised. So what is the data being used for? How is it being used? Does it matter if the quality is there or not? Lossless compression, there is no compromise of the quality. Lossy compression reduces the size of data. Think about pictures, people. Is it important that I know that there was one flick of yellow in a tree in the background, or can I make it all green? Okay, lossless compression does not reduce the size as much. Algorithms that use lossy compression, transform coding, discrete cosine transform, discrete wavelet transform, fractal compression. Do you need to know those? No, probably not. You just need to know that there are algorithms. Again, over here are different algorithms that use lossless. Do you need to know them? No, but you need to know that there are algorithms for that. Whoa. Lossy compression is used in images, audio, and video for the most part. Lossless compression is used in text, images, and sound. Lossy compression has more data holding capacity. Lossless is less. Here is I've got them on the big screen and they look terrible to me. They don't look that bad and small. But the one on the left is lossless. The one on the right is lossy. Do you see a difference, really? And there are tons of examples out on the internet where you can bring them up and show the kids. This one's lossless, this one's lossy. Does it matter? And most of the time, the answer is no. You're going to see more lossy compression used in pictures than in anything, okay? Oh, I'm already up to a question. You guys ready? Here we go. Which of the following is an advantage of lossless compression algorithm over a lossy compression algorithm? I can't see all these. Oh, I can now. A lossless compression.
Go ahead.
I threw you guys over to the side. Okay, I'll let you read them. I don't need to read them to you.
All right, type your answers in the chat and we will monitor and see how you're thinking. And then Marsha, I had a couple of examples of lossy versus lossless after you're finished with this question.
Excellent. Would you say it's fair that there's going to be something about lossy and lossless on the test in some form?
Almost always is, yes.
Yeah.
Just from examples that are on the practice tests and from responses back from students.
Yep. I mean, it's just, it's something they want to make sure you understand. So it's going to show up in some form. Lossy versus lossless.
All right, we're seeing a lot of B answers here.
Well, let's see what we got. Hey, look at that. And the answer is B, because you can never retrieve data which was not transmitted. If it's lossy transmission, not all the data is going to go. So you can't get it back because it was never sent. Okay.
All right. Yeah, and I wanted to mention real quickly about a couple of examples of lossy versus lossless as well. A couple of examples that I've seen in personal examples. Number one, if you have ever ordered one of like a blanket or an Afghan or something like that, in which you've had to pick pictures ahead of time and choose pictures to put on those blankets. And sometimes wherever you're ordering it from, they won't even let you do this. But if you choose pictures that have lossy compression, then when you get that blanket back, then your pictures are going to be so pixelated that you can't even necessarily tell what they are. And so that's one example. The other example is, you can't see it on the wall here, but if you've ordered canvases of pictures, and if you use pictures or use digital images that are lossy to begin with, and you put those on, say, for example, a pillow or a stretch canvas or something like that and order it, again, you're going to get a pixelized image when it comes back to you. So those are a couple of examples of where you can really see a difference in lossy versus lossless compression.
Behind me on the wall back here is a poster printer, which is used out of my room. When I'm lazy, I'll take my phone if I have a picture on it and email it to myself to get it to the poster printer. But the fact that I send it through email is lossy compression. It looks great on my phone, but by the time I send it through email and then try to put it onto a poster, it has lost a lot of its value and it's fuzzed out. If I take my phone directly to that computer and plug it in and just take it from the phone into the poster software, I get a much better result than I do if I try to email it, because the email algorithm is a lossy algorithm. So there's another good example for you. All right. Anybody got anything else on lossy, lossless? Again, if you're taking this test, make sure that's something you understand. I'll be really, really surprised if you don't have at least one question covering lossy and lossless in some way. All right, next question. A team of researchers wants to create a program to analyze the amount of pollution reported in roughly 3,000 counties across the United States. The program is intended to combine county data sets and then process that data. Which of the following is most likely to be a challenge in creating this program? This has to do with how computers use data.
All right, answers in the chat. Let's see what you come up with. We'll do a little comparison. And you all have the benefit of having answers because you have the slides too, but one of those things that hopefully you're challenging yourselves as you move.
I feel like it was fair not to put the answers and the explanations right behind the questions, because if
Oh,
you're going
yeah.
to use it as a teaching thing, you need, it needs to be there.
Exactly. I'm seeing a lot of B's, Marsha.
A lot of B's, B as in boy.
Lots of B as in boy.
Good. You have to have the same algorithm or the same protocol. Let's not use algorithm. Let's use protocol. Protocol is the computer word. The protocol is the set of rules. You've got to have the same protocol from the sending to the receiving. The data has to be exactly the same. Okay. Both sides have to understand the rules before you can share data. All right. Which of the following is a true statement about data compression?
All right, answers in the chat.
I didn't think this one was terrible.
Seeing a few answers come in. Let's get a couple more answers and then we'll talk about this one.
Okay.
All right. I'm seeing a lot of D's. D's and
Good. And the answer is D. We talked about this 2 places earlier in the presentation. Texting is really data compression, so it isn't only used to transfer over the internet. You can compress anything. Contractions are compressions. Regarding answer B, we must remember that not all data transfer is compressed, so that rules out answer B, because if no compression is used, the file is the same. Or if a compression key is sent, it can be restored as long as it's lossless. Regarding answer C, compression has nothing to do with data transport. The file may well be intercepted, but if the user may not know what to do with it if they get it, that doesn't mean they can't get it. That just means they don't know what to do with it. There are always going to be trade-offs in data compression decisions. So the answer is D. All right, this one requires some thinking. I had to think about it. I did all these before I put them in here without looking at the answers. Digital images are often represented by the red, green, blue values, the RGB triplet. I wouldn't be surprised to see something about RGB triplet come up of each individual pixel in the image. A photographer is manipulating the digital image and overwriting the original image. Which of the following describes a lossless transformation of the digital image? Which of these 4 is lossless? Can you get back to the original?
Okay, answers in the chat. Give about 30 seconds.
I really like this one.
All right, I'm seeing a lot of C's here.
See, you guys are smarter than the average bear, as the saying goes. The answer is C. If a negative of the original image is made with the triplet, values will be computed by subtracting, and then you can restore it by subtracting the new value instead of the old value. It's lossless because you can get it back. All of the other choices in some way or another were lossy. This was the only lossless answer. Okay, see, I didn't make near enough, but that means we can talk about create some. And I'll try to find us something on create if I can. Here's a lossy and lossless compression video, the no cookies version of it. There's a practice Kahoot from with code.org information. And that is my last slide. Now,
Okay. All right, well, let's pop open the chat. Any questions that you have about lossy or lossless compression?
I'm going to stop sharing for a minute and see if I can find something on create.
Okay.
And then I'll come back if I can.
Well, I think probably Marsha was looking at pulling up the rubric specifically. And because I know that a lot of teachers right now are, well, they're in the midst or in the middle of getting students prepared. And so there may be some questions about the content and how to adjust content and curriculum and things like that, but also about the create task and how it's going to be scored. I know that Marsha's been a reader in the past and she's scored the create task. I know that some other folks on here have also been readers for the both the create and explore tasks. So
All has. We spent a memorable week sitting next to each other arguing about stuff. In a good way.
Yes, we did.
In a good way.
Hey,
We were
Sherry,
arguing whether to make points or not.
Sherry, we were elbow partners in Kansas City.
Yes, I heard about that. So for those of you that are not familiar with the way that the create tasks and explore tasks are scored, and they're scored remotely right now, but when the world does get back into swing, world gets back into some kind of normal status, then one of the ways that explore tasks and create tasks are scored is that you have an elbow partner sitting beside you physically at a table. And if you have the scores go through, score the tasks. And then if there are any questions that come up about questionable aspects of it, then you can ask your elbow partner and talk about your elbow and talk about it with your elbow partner to come to a consensus. And that helps to just include, or it helps to increase the reliability of the test and how it's scored.
Okay, for everybody, I'm sure already knows this, since there is only the create and the AP exam. The create is 30%, correct?
Yes.
And the AP exam is 70%. So when they're doing their create, they are talking about 30% of their grade for the test before they ever take the AP exam. Couple of things. One, they are no longer allowed to use audio with their videos. I found this out the other day.
Yes.
In other words, you cannot, used to be able to do like a 1-minute video and talk about it while it was running. AP has determined that there may be some cultural bias in hearing people's voices that may not be intentional, but may be there. So they've cut that out. So the video does not have any audio with it. I can say as a scorer, that's a good thing because some of the video, the audio was so low you could barely hear it. And some of it would just blow your eardrums off while you were trying to listen to it. So I don't think this is a bad thing. But what this means is their write-up has to be that much better. Has to be that much better an explanation if they don't get to talk through the video. They just get to show it running in the video. Okay, so there's a big difference. So if you're scoring, this is the rubric you have to use to score. So this is what they need to be writing toward, because this is the only thing a reader can use. Your decision rule is on the first part, row 1, everybody should get row 1. Okay, they should. Everybody should get row 1. Because all you have to do is have a video demonstrating the program running. It has to be a video. And if you pull it up and you see the program running, you got the point there. Okay. The only way you don't get a point there is if they send us a blank in place of that. Okay. Okay. There are some other differences. Somebody who maybe has studied a little more than I have can jump in here anytime. On row 2, they have to have the abstraction. They have to have 2 program code segments. One that shows how data has been stored in this list, okay? One that shows the data in the same list being used. So their program this year has to have a list and has to use data from that list, okay? That's new. You didn't specifically have to have a list before, but you do now. Is there anything lighting up? Sherry, I'm not looking at chat.
The one question that came up is, are there a picture of the changes from last year to this year? And Paul, if you would like to post that, we can share it. That would be nice. Thank you.
Yeah, I'll have to get it off my phone.
That is fine. We'll wait for you.
Okay, so there we do have this was old and this is new. Great. Let's see. Row 3, managing.
There was another question that just came in about, could you use a group instead of a list?
A specifying list. Now, is that based on program language? Is a list called a group in a separate program language? I don't know.
So that is a good question. Most programming languages use lists, arrays, things like that. I haven't heard of a language that uses group, but that is a good question. Is that part of a specific programming language?
if that's considered what a list is in the programming language, then you can use group. However, if you have a list option in your programming language, you've got to use list. Okay.
One note that I wanted to mention too before you move on, and this is particularly for students, but one of the things that I know my students used to get really bent out of shape about is whether or not their entire program worked exactly the way they wanted it to work. To be able to submit your create task, your entire program does not have to meet all of the checks on your own checklist in your head. It just has to meet these rubric criteria. So as long as you are meeting the rubric criteria and you have a running section of the part that you're highlighting, that is the finished criteria as far as the create task. You can go back and finish your create task and make it as perfect as you want later on. But as long as it meets these criteria and you have those hit, don't get all stressed out about trying to make sure that you have the perfect program to submit for your create task.
And let me say this, because I've seen kids get bogged down in this before. They want to go over the top because they want to really impress the reader with how much it does and how fancy it is. And what you've got to understand is the reader's going to look at it for a very condensed amount of time just against this criteria right here. And even though it's great, they're just looking for these things. I promise you, they're just looking for these things. On lists on row 2, look down here. If the use of the list is trivial and does not assist in fulfilling the program's purpose, if you wrote a program and then thought, oh shoot, there's no list, and you went back and threw one in there and pulled one thing out of it that had nothing to do with how the program works, we're not supposed to give you the point. Even if you have a list there, if it's not valid to the program's purpose. Okay? So just keep that in mind. It's not something you add on later. Let me also say this, because I've had kids do this in the past. They have worked together on a program. Is that even allowed this year? Paul, have you looked at that? I haven't yet. Yes, I've got a thumbs up. Okay, here's what happened. 2 of my boys worked together on a program, and they also, even though they knew they weren't supposed to, worked together on their create write-up. And when Maria's like, oh, no. What happened to those 2 boys is the first one that went through just fine through the copyright software. And the second one that tried to go through got flagged for copying someone else's work, and he didn't get credit. And it was the luck of the draw, which one got there first and got credit and which one didn't. And they had been told, you have to do your own write-up. Even if you work together, most of it has to be you. And what happened is one of these kids was really good and one of them was on his coattails. And unfortunately, coattail kid got the credit and really good kid did not. So make sure your kids understand. I strongly recommend that they do their own work. I recommend that they talk out problems with each other, because it's easier to fix somebody else's code than it is to fix yours. But I recommend that they do their own project. I can't make them, but I've seen it really backfire. Okay.
And one thing too, if you do have students that are working together, and one thing that I used to do with mine is that if you are working together, you treat this as a software project, whereas you have assigned duties. And you're only allowed to talk about your assigned duties or what you are responsible for in your write-up. And so that's, if students did want to work it out together, or work out their create test together, that's one way that you can go about it, and divvy it up so that they're not plagiarizing one another.
Okay, and that was a newbie error on my part. That was the first year I taught it. And you know, I know to watch more closely, even though I can't say much about it until after they turn it in. All right, row 3, managing complexity. A program code segment that shows a list being used to manage complexity of the program. Explains how the named selected list manages complexity by explaining why the program code could not be written or how it would be written differently without the use of the list. So not only do you have a list in there and you've got credit for having a list that's part of your program, but how does your list make your program run better? How does it manage the complexity of your program? Okay, so, and we can only consider whatever they've put in response 3B when we're answering this. Now, having said that, when I was out in Kansas City, they said, give them credit if you can. Give them credit if you can. But we could not unless it met the criteria. Okay. Questions there, comments there, complexity? Okay.
And as far as changes go, the addition of lists to the criteria is the huge one that I've seen.
It is.
But it has not been part of the past rubrics.
Yeah.
And
And,
Marsha, I just shared the link to the photo in chat.
Great. That's excellent.
Paul, I'll pull that up as soon as Marsha gets finished going through the rubric.
Okay, I'll go through these and then we can pull that up and look at it.
Excellent.
Sounds good.
Procedural abstractions, row 4. You have to include 2 program code segments, one showing a student developed procedure with at least one parameter that has an effect on the functionality. So not only do you have to have a procedure, but your procedure has to pass this parameter this time. Okay, not just it has to have a parameter in it. Okay, student, and you've got to show where it's being called in the program. Okay, you have to describe what it does and how it contributes to the function. Okay. In other words, what does it mean by student developed procedure? Not a canned procedure that comes with your software, but one that you developed for a certain purpose within the program. Okay, there are certain ad hoc procedures that some programming languages come with. You can't just grab one of those. This has to be one that has work in it that you put in, and it has to make your program better. Okay. Questions, any comments there? If I'm going off the rails, somebody reel me back in. Okay.
Good so far.
Okay. Let's go to the next one. Row 5. Let's go back to row 5 since I skipped it. My computer's being weird. Algorithm implementation includes a program code segment of a student developed algorithm that has sequencing, selection, and iteration. This is pretty new, I think, in some ways. Before they used to say you got to show some math. Now you have to show sequencing, selection, iteration. Okay. Okay. The algorithm being described can utilize existing language functionality or library calls. So you can have canned procedures here. Okay, but they have to work for the betterment of your program. Selection, iteration, and sequencing. Okay. An algorithm containing sequencing, selection, and iteration not contained in a procedure can earn the point here. So it doesn't necessarily have to be inside the procedure. It can be, but it doesn't have to be here. Okay. Okay. Questions about that? If the code segment calls on student developed procedures, procedure called from within the, you can read that as well as I can. Okay. So you have to have, bottom line, sequencing, selection, and iteration have to be present. Row 6, testing. Describe 2 calls to the selected procedure. Each call must pass a different argument that causes a different segment of code to execute. So when you call your procedure, you have to call it twice and pass it a different parameter both times. And the parameter you pass must cause it to do something different each time. Okay. And you have to identify the result of each of those calls. Okay. procedure's not identified, if you don't have a procedure, you don't have a parameter, you don't get this point. Okay. Okay. Anything there? Remember, they have to call it twice. This is bottom line. It has to have a parameter. You have to send 2 different parameters. You have to call it 2 different times, and it has to do something different based on the call. Okay. That's testing to make sure it works. Oh, that's it.
All right, real quick question here. So sequencing, selection, and iteration must be just used somewhere in your code. That's according to Rob.
It says in the rubric that it does not have to be in a procedure, but it must be in the code somewhere. That's what the rubric says, right? Right. Yeah. Right here. There you go. So it does not have to be in a procedure to earn that point, but it has to be there. Okay.
Okay. All right, any questions about the rubric? And now from students, from teachers, and whomever, for students, one of the best things that you can do is to take that rubric, because that's kind of your Bible, and just create a checklist. And when you finish or create tasks, go through the checklist and make sure that you are meeting all of those criteria on the checklist. If it says and in the rubric, both of those things have to be present. If it says or in the rubric, only one or the other has to be present, just like using Boolean logic.
It really helps the students. It really helped me when I was first getting started, and it really helps the students to look at the examples from the AP site, the create examples that are on the AP site. It's worth half a class period to at least walk through a really good one for them to see what's expected and what a really good write-up looks like. It's well worth your time. And it's worth your time at the beginning, before they start much on it, to go through there so that they can see where they're supposed to end up as they're getting started.
Yeah. One thing I used to do in the classroom is I would take, I took the code.org unit on the create task. And my students didn't work through the create task for the whole 12 days, 15 days, 20 days, depends upon the hours that you have in your class. And the examples, yes, to my understanding, those new examples for 2021 are based on the new rubric. And so you'll have those used on the new rubric. And I'll double check that just to make sure. But one thing that you can utilize is that students do not have to work for the full number of days, 12, 15, or 20, whatever number of days that it takes for you to get your hours in. They don't have to work through those straight. You can break it up in the middle and go over an example from College Board's site. And that way you're not telling students, you're not getting direct instruction from your teacher about your particular create task, but you are getting models and examples that you're able to use to compare against your own. So just so that you know that you don't have to work straight through on a create task and just start on day one, finish on day whatever. You can break those up in between as you need to.
Once you get them started, I have some health issues, so I have some sick days here and there while I go to doctors. This is a really good sub plan. Once you get them started and they understand what they're doing, a work day can be a day that a sub is there, because you can't give them direct feedback on their project anyway. So keep that in mind. If sub days come up, and if you've gone over it and you feel like they're ready to get started, tell them it's a create day and let them work through.
And teachers, for those of you that are comparing and contrasting, students, it's not going to make as much of a difference for you because you're just using the 2020, 2021 criteria. That's a tongue twister, isn't it? Anyway, so you're just using that criteria anyway, but for teachers that have taught it in the past, here are the major differences from last year to this year. Thank you, Paul, for sharing that. And thank you, Marsha, for going into the detail. But notice that the differences are in 2021, no audio narration. Marsha brought that up. The demonstrates the input, program function, the output instead of the video response there. No description of the development process is required, which that's different. And then lists, which we mentioned that earlier, that lists were very much a part of the changes and must include all 3 algorithm sequence selection and iteration. So that's a good compare and contrast. And yes, that came from PopFizz, Paul. I saw that up there, and PopFizz has done a really good job with making some of the changes and some create task help sessions for teachers. All right. Any questions about that, about the create task? Now is your time to ask. Or if you have some comments or suggestions of things that you are working on or doing with your own particular students, teachers, we'd love to have your input as well.
Let me say this to make people feel better. I am behind. We are all behind. Unless you're Superman, you are probably not going to get everything covered this year in the situation that we're in. Okay? You're going to do the best that you can. You're going to help the kids do the best that they can. Don't feel like you're the only one in the world that is probably not going to get everything done this year. I mean, I was in a group the other day and everybody was talking about how far behind they were and how they felt like they hadn't gotten enough to the kids yet.
And that's a good segue into the segue into how you're adapting to make sure that students that have all their content. So students, how you're adapting, how do you feel about working on your create task? Because I know this is for probably the first big project you've worked on.
Let me say this for the students that are out there. How do you eat an elephant? 1 bite at a time. How do you do a create task? 1 piece at a time. Tackle the plan first, and then have a good plan before you go forward and try to do anything. If you're like my kids, my personal kids, and my kids in class, you want to get to the part where you're doing something. You don't want to do the planning. In this particular instance, the planning is going to be key to saving you lots of headache. So figure out where you're going and what you're going to do before you try to start coding, kids.
Good deal. Question that was in the chat box. How do you find the examples on the College Board site? And
it's always a challenge to find anything on the College Board site.
I'm going to see if I can pull those up for you here, because it's almost like a scavenger hunt sometimes trying to find them.
Once I get there, I'm excited about it, and then I get out and forget how I got there.
I'm sorry. You're so right, Marsha. That's like the picture. I didn't know where I got it from. It's like you take pictures as you go, and then you don't remember where you got it.
And I'm pulling those up for you. Another question, do you recommend just making an app that fits this rubric, or should students pick something that interests them, then try to make sure it has the things in the rubric that it requires?
Depends on how their brains work. The way my brain works, I have to have a plan going forward to make sure it's going to match the rubric. I've seen kids get so involved in what they want their program to look like that they don't meet the criteria of the rubric. So while it's good for it to be something that's very interesting to them, I'd go happy medium. I wouldn't just turn them loose to, because I have a kid that made the last project he did so much harder than he needed to, and he just got bogged down in it. So
it is one of the dangers, but and with any kind of test or with any kind of exam, that's one of the dangers. Absolutely. So I would say the answer to your question, Steve, is yes. Because if your student can find the happy medium and be able to do both, find something they're interested in And then as they're developing a plan, use that rubric to make the plan.
I know they want to
enjoy.
Yeah, I want them to enjoy it, but if they're doing it to impress the readers, honestly, the reader is going to look at it very quickly, very thoroughly, but very quickly, and they're just looking for it to meet those points. And that's it.
Follow the rubric. You got it.
Yeah.
And I put the link in the chat. If you go to the exam page for AP Computer Science Principles and you scroll down, if you scroll down, then it has all the examples there that you can use. So it has the sample video and the sample written responses, as well as the scoring guidelines and the commentary. And Marsha mentioned it, but it is excellent to just take a full day and go through one or two examples, the video, the written responses, and then the guidelines and the commentary, and actually sample score. Have your students go through and try to score it like a reader, try to be a reader, and score it like the reader does. You're going to have the commentary there. So that is going to help you more than anything to understand what in the heck you're doing with the create task.
Caution your kids. I know that we caution them and caution them and caution them. I keep telling my kids, if you can find it on the internet to copy it, I can find where you did to prove it. So be very careful. Tell them to be very, very careful.
All right. Students or teachers, do you have any questions about the create task? And here is what many of you seen this, students you may not have, but this is the section that you go to, and that with that link in the chat, where you can look at the sample responses and look at the scoring guidelines and the commentaries, and it usually tells you what their scores are.
And these aren't all the best. Some of these are bad. So, it's going to show you what scores well and what doesn't.
Yeah. So what to do and what not to do. All right. Paul said he did this last year with 2 out of the 4 that attending this the session, and then they got qualifying scores of 3s and 4s. So
dealing with the using the rubric and scoring some samples.
Yeah. Some of the absolute best learning that you can do. Again, students, a lot of you are still at home, and this is something you can absolutely do on your own to help understand what this is going to be like. This is not just for teachers. It's for students as well. Taking ownership of your own learning. All right. Any other comments? Marsha, you have any closing remarks here that you want to make?
Other than I hope this did some good for somebody. I hope this helps some.
All right.
You're welcome.
Awesome. We got some jazz hands from Maria. I love the jazz hands. And thank you from Kimberly. I'm going to go ahead and I'll show you the last screen. Like I said, we are videoing this particular session and recording this particular session. And so I'm going to go ahead and just kind of finish up and give you that wrapping up information there. You can always go back to the bit.ly link and take a look at it. Here you go is that final information. If you want to contact me at Advanced Kentucky, Dr. Sherry McGuffin, STEM coordinator, there's my email address. Feel free to email me anytime. Advanced.com is our website, and Aaron Timmons, who is he is the person in charge that makes all of these content review sessions happen. He's the content director for mathematics at Advanced Kentucky. Marsha Bertram at Wayne County. Email Marsha if you have any questions for her. The handouts and recordings are going to be available at the bit.ly link, Math CRS, and at bit.ly Advanced Kentucky, and click on Math Computer Science at the top. And then the next discussion for computer science principles is going to be on March 20th, talking about algorithms, developing programs, and more about the create task as you're wrapping that up with Joanna Stevens. And so anyway, we will look forward to that March 20th session. And if you have any questions, otherwise, we're just going to be signing off, and have a great weekend. Stay warm. If you're already warm. If you're in Kentucky, maybe we'll get warm.
At least I have power. That's my thing.
Buddy.
Bye, Sherry.
Marsha,
Bye.
thanks again.
You're welcome, Paul. Good to hear from you.
Yep, same here. Sherry, be good.
Always trying.